track any obstacles which is ahead of the vessel, since there is a communication between the waves that are sent and reflected back. This is an illustration of how Earth observation satellites are installed in space. And at least this also shows how the satellites move around the orbit and capture images at a particular point and a particular speed. So this brings us that if the satellite moves very fast around the image, maybe it moves at the speed of the image of the orbit, that means the temporal resolution may be good. And also this may lead to capturing images of higher resolution. But it is very tactical. You may not find that both images, an image has both the attributes of a good image, good resolution, and good temporal resolution. Maybe let's look at the common attributes considered before using a downloaded image. Most of the attributes that are considered, most of them, they look at the spatial resolution. And the spatial resolution, at least this has been highlighted in the previous class, but no problem. So what is the spatial resolution? Here we mean the number of pixels utilized in constructing of one image. Meaning, the more the pixel, the higher the resolution. As you can see, our three images, image one has detailed pixels, meaning that it has a good resolution. And it has a higher resolution. A higher resolution does not mean bigger in number. A higher resolution means smaller in number in terms of meters per pixel. When you look at the three images, you'll find that the one with 300 meters is a bit faint compared to 100 and 300 resolution. Another aspects that we might look at before considering an image for use is the temporal resolution. The temporal resolution is the time taken an image to revisit the starting point of observation. For example, if this satellite takes 2 days to move around up where it started from, that means the temporal resolution for the image captured is 2 days. If the satellite takes 1 day, that means the temporal resolution of the image captured will be 1 day. And if it takes 16 days, that means the time it took to come back to the starting point is 16 days. And that is what is qualified to be a temporal resolution. Now, let's look at the different imageries that are obtained from Earth observation satellites. And there are different spatial resolution, temporal resolution, and their availability. Then we shall make a judgment. Which image can you go for a particular task? Landsat image. The Landsat satellite was launched in 1971, and therefore images are available for download from 1972 to date. It has a spatial resolution of 30 meters and a temporal resolution of 8 days. That means the Landsat satellite moves around the orbit, moves around the Earth and comes back where it started from, meaning that took 8 days. However, the status for this, it is free. You can download it from a number of public websites. We have the MODIS. The MODIS was launched in 1999, and data is available from 2000 to date. And it has images of spatial resolution starting from 250 meters, 500 meters, even 1 kilometer. But the temporal resolution, depending on the weather, is also free. You can get it. We have also Sentinel-2, Sentinel-3, Sentinel-4, Sentinel-5. For Sentinel, you can take any, either 3 or 4, depending on the task that you're going to do. 4 and 5, you'll find it purposely for water tasks. So it depends, but for land use, land cover changes, vegetation changes, you'll go for 2. It was launched in 2012, and images are available from 2015 date. It has a spatial resolution of 10 meters. And the temporal resolution for these images are 5 days. You can also get it for free. However, despite the spatial resolution of the free images and the temporal resolution, we also have commercial images. These have, the calculatives of these, they have a good resolution, spatial resolution, but they will never be for free. You have to buy per square kilometer. We have Equinox satellite sensor. It was launched in 1989, and images are available from 1999 to date. When you look at its spatial resolution, it is really good. It is less than 1 meter. When you compare that image to the rest, this looks to be very clear with good details. The temporal resolution is 3 days. That means this satellite sensor takes 3 days to come back to where it began. The spatial resolution is good. The temporal resolution is good, but compared to its spatial resolution, it's not all that good. There are other commercial satellite images, Spot 6, you can Google, you'll find them, you'll find their spatial resolutions, but at least they are less than 1 meter for all these commercial satellite images, and their temporal resolution is between 3 to 4 days. A question. After all this, which type of image would you prefer for disaster management and finding out particular assets that have been destroyed by a particular disaster? Let's say flooding. Maybe, Chair, you can unmute anyone who is willing to answer.
Please, if you have an answer to the question he's asking, please you can put your hand up and unmute and then give an answer. Anyone? Yeah,
yes.
I'm seeing Emmanuel Omeya, your hand is up. You can please unmute.
Thank you very much. Like they mentioned, my name is Emmanuel Omeya. In management for disaster, especially the way he has brought it out, like you want to know which specific property was destroyed. So that to me, it means someone would need a very high spatial resolution imagery, meaning that in such a situation, I would go for Equinox or maybe any other better, whereby I can be in position to see even the build. If it was a building, I can easily see, even if maybe flood and it was maybe a small holder farm, I can still see it, as compared to maybe using Sentinel, where anything which would be smaller than 10 meters may not be clearly seen, or you can't see the damage that was put on it. Yeah.
Okay. Yeah, Emmanuel is right.
Can I add something?
And the fact he based on, maybe you can mute. Add something, please.
Yeah, I wanted to say that Emmanuel is right. But also in terms of flood, we can consider the temporal resolution. You know, if there is a flood may happen, but it can take longer than the 5 days. So if you consider the only spatial resolution, it is nice because you can see the details of what is happening. But once the temporal resolution is high, like 5 days, you can miss some events. Thank you.
Yeah, thank you. I didn't pick your name, but I think you misheard Emmanuel. Emmanuel was comparing Equinox and Sentinel, and he said he prefers Equinox because, one, it has a good spatial resolution. So I was complimenting that, you see, Emmanuel went for Equinox because it has a good spatial resolution, and ignored the temporal, which is okay. If someone asks me, but you didn't consider the temporal resolution, why didn't you go for MODIS? One, MODIS doesn't have a spatial resolution. This I'm answering, I'm reacting to someone who said MODIS is the best. MODIS can't be the best here. If at all we want details, which assets were destroyed. We want to know the particular houses. We want to count in numbers, 1, 2, 3, 4, 5 houses. So Equinox, since it has a good spatial resolution, you can see even the details. So we can go for that. Besides that, I don't think a flood can take 1 day. The temporal resolution is not all that bad. So for that question, I think we can go for Equinox. So what if we want vegetation health? What if we want to monitor the vegetation health over time? That's another question.
Yes, if there is.
We don't want small details, but just monitoring the vegetation health. Let me put it in layman's language. Maybe some people may not understand the vegetation health. For example, you have a garden at home. I need to monitor until the harvest time. Which data would you go for?
Again, yeah, if you have an
I can
answer,
see, I
you
think
can.
they according to what? Should I continue?
Repeat the, you can
for
repeat
Yes,
temporal data.
Okay, let me repeat. I repeat the question. So what if I want to monitor the status of the vegetation health in my garden? For example, maize. I want to know how my maize is changing over time until harvest. Someone is telling me Landsat?
I think you have to
Someone
go
is
with the
telling me
one with
Sentinel?
higher temporal resolution, which is the MODIS now.
Higher what?
Temporal resolution.
Yeah.
Which is MODIS.
Good. Someone is telling me modules. You're very right. Someone has modules. You're right. Because we want to read at least every change. When you look at our modules, here you ignore the resolution, but at least the temporal, because you want to see the changes every after day. When you look at our modules, at least it has a 1-day temporal resolution. So here modules qualifies. And that's why we used modules in our assignment for land productivity, because we wanted to know the change of vegetation over time per year. So this is how modules have used Equinox. The disadvantage of Equinox in this scenario
when
one.
you
Continue.
but I wonder these models have the spatial resolution
I think, I don't know if I'm off. Can you hear me?
Yeah, we can
Is a very,
hear.
very
Okay,
valid to
someone
others.
talked
If you
about,
want to set an image, I think.
okay. I'm not getting you, but at least I've got a hint what you're talking about. You're talking about modules, the spatial resolution is not good. One, I'll take the spatial resolution of 250 meters. It may not be good compared to the rest, but remember, we want to get detail of how vegetation is changing. We don't want to miss any detail. 1 year temporal resolution is better than 8 days. By the time you go to your garden, after 8 days, that means the plant will have changed. Someone is telling me about Sentinel.
Hello.
Sentinel would be okay.
Its resolution is not so good.
Hello.
You can't see properly
Yes,
what
please.
picture.
I beg your pardon.
Hello.
May I think the modis wouldn't be very good? Yeah?
Yeah.
Yeah, because the resolution is 250 meters, and yet we said when we were learning about land productivity, you have to factor in climatic changes. So if the resolution is not good, and perhaps there is a pest infection, then you'll not be able to capture that information. So may I think I would rather take the Sentinel where the resolution is clearer and the days are not so many. In 5 days, you haven't noticed that big change. So me, I'm thinking if the resolution is not so good, then you may not capture the climatic part of the pests and perhaps, any invasion to the productivity.
Yeah, thank you so much. But right now we are not talking about pest monitoring. Though your point is correct, but there's one I'm going to answer it. But we are talking about
Hello.
how the vegetation. Chairman, maybe mute so that I can take over.
I'm muted. Maybe there is someone who is unmuted. Please, I request that you keep all your microphones off. And if you want to say anything, just put up your hand and that's when you'll be allowed to unmute. Thank you. Mr. Maga, you can go on.
Thank you. So this table is good that I can see we are understanding the argument behind different resolution. Yeah, his argument is okay, but we are not doing pest monitoring. Yeah. So one, what you have to note when you're selecting such images. Not all images have all the factors. It can't be with a good spatial resolution, then it will also have a temporal resolution. So other factors may come in so that you can make a decision. However, all your answers are correct, depending on the task that you're going to do. So I think we can continue. Maybe we can also have an overview of the remotely sensed data. How are they applied? Remotely sensed data are applied in marine environment. As we had an example on the water vessel, it would at least track the route. It would also capture the details beneath the ocean. Atmospheric and climatic change, remotely sensed data can be used to analyze the pollution, to forecast the weather. Then emergency responses, remotely sensed data can also help us to analyze the different disasters, which can help us to mitigate and respond immediately. For example, floods, landslides, among others, not forgetting earthquake. Then fire management, using a number of indices, we can We can calculate the fire burning index and identify areas that have been burnt, and also predict other areas that can be burnt, maybe in the forest, maybe in the cattle corridor. Then there is also remotely sensed data can be used in hydrological modeling. With the use of GIS tool and remotely sensed data like the digital elevation data, we can delineate water management, and at the end of the day, we can be able to calculate the statistics of wetlands within a particular catchment. And then there is also land management. Remotely sensed data can be used to analyze the changes in land cover. Using remotely sensed data, you can know different land covers, how have been changing over time. And at the end of the day, you can have a trend. For example, you can have a trend between maybe 1986, since they are available, as we said, for Landsat. This data is available from 1972. We can analyze from 1986, 2000, and 2020, and at least we can have a trend of how a particular land cover has been changing. And this can give also a decision maker a better idea of how to plan for the future. Remotely sensed data under land management, you can also analyze the crop phenology. Crop phenology, this is how you can analyze the start and the growth of a particular growing season using a particular satellite imagery. So when you're identifying the start and the end of the growing season, this will also bring an argument. What is the scale and coverage of what is the scale and coverage of the area before you do this analysis. Besides that, under land management, we can also know the status and the trend of a vegetation cover within an area. For example, we might want to know how the vegetation health has been changing over time, maybe within a cattle corridor, maybe within even an entire country. So some of these vegetation indices that can be used to track the vegetation health using satellite imagery. This may include the normalized difference vegetation index, which we know as the NDVI. There is also SAVI. This is the soil adjacent vegetation index. There is also enhanced vegetation index, that is ENVI. So all these indexes are used depending on the task and the expected output of interest. For example, NDVI will give you the general vegetation index of an area without eliminating other factors. So elimination of other factors may also depend on the additional data sets that you're going to use. For example, if you want to eliminate the soil reflectance, you can use SAVI. SAVI can be used if at all you don't want the output analysis of, okay, you may not want the soil variables within the NDVI. So because the soil itself can give a reflectance, and at the end of the day, you may think maybe an area with a bare soil, it has a particular type of vegetation. Maybe let me give you another example on this of soil reflectors. When you're interpreting these images, you'll find somewhere it is black, but for real, it is not black, and you might interpret it as vegetation, yet it is bare soil. So to remove all the soil reflectors, we can use SAVI. For example, you may also analyze maybe the land productivity, like what we did. Soil was also a part of the data set. So there was no use of using NDVI because it would be to take in the values of soil. So we decided to use the survey, which is the soil adjacent vegetation index, so that it can eliminate the soil value reflectors, the soil reflectors values from NDVI. And that's how NDVI qualified to be used. MV is usually used in areas with a number of tree covers, whereby if at all you do your analysis, you might find that the entire area is it has a higher vegetation status. Yet it is these are the trees, the tree reflectances that are misleading our output. So if you use MV, it will at least remove the canopy reflectancy.
Mr. Mugaya, I request, I think your screen sharing paused.
Yes, please.
I think your screen sharing paused and we can't see the current slides. So I request that you check it out so that we can view the slides. Thank you.
You can't see my screen?
We can see, but you paused on some slide. I think that was application of remote sensing data. That's the slide we ended on.
Yeah, that's where I am. I'm still there.
Okay.
I'm still there.
Okay, please.
I'm trying to bring clearer what I've highlighted in red, vegetation status using different indices. I'm trying to bring the indices because we don't have them in the slides.
Oh, thank you very much.
Yeah. So before we land to the main core of the training, the survey, I've explained how survey came about. These are the vegetation indices. We have brought the different different satellite imageries. We made an argument, compliments on the different resolution and the temporal resolution, and maybe the scale. And I showed you why we brought up models. Though all your answers were okay, but the issue of the scale coverage comes in here. This project was covering 10 countries. So using Sentinel for 10 countries, as we said, the rendering would be very poor on a particular machine. All machines, I'm thinking they would crash. So sometimes even the equipment that you have can lead you to use a particular data sets. Any question before we start boarding? Okay, let me continue. So this I've explained at least a bit of it in the former slides. So we decided to use MODIS, as I've been saying, and it collects data on a daily basis with a spatial resolution of 450 to 500 meter resolution. We have seen this. We have talked about the NDVI and why we are using the survey. So within the formula, the survey formula, which is the ratio between the red band reflectance values and the near infrared band value reflectances, we shall add the L factor, which is the cell brightness correction. The cell brightness correction we used was 0.5. We used 0.5 because this is the commonly used value for most of the researches, and especially that are done on a global basis. But however, on the small scale, you can calculate your cell brightness correction factor and should be between 0 to 1. When calculating the soil brightness correction factor, you have to put into correction the type of soil, its organic matter, the pH, organic content, and this K factor. So this could be tedious, and besides, the accuracy may not be good. But at least a number of research that have been done, 0.5 has been qualified to be used as the soil brightness correction factor. So that's the formula, and at least we went ahead to show however much we are going to use survey, at least someone else with a small scale, small plot, who prefers a better resolution can go for Landsat, can go for Landsat 8, can go for Landsat 4, Landsat 7, can also go for Sentinel data. Here are the bands that represent the near infrared and the red reflectancy will change. So therefore, if you're using survey, we shall use band 2 minus band 1 over band 2 plus band 1. Remember our formula, it is 1 plus 0.1, 1 plus L. Our L qualifies to be 0.1. Therefore, anywhere where you see L, put 0.1. And that's how we got the figures. The same with the survey, sorry, the same with the Landsat, the same with Sentinel. When you download Sentinel, the near infrared is band 8. So it is not mandatory that a particular band that represents the near infrared in modules will be the same in Sentinel. All these change according to the spatial resolution. So the formulas are there. We had an argument which images should we use. So if you prefer to use the answer, at least the formulas are there. Somehow we asked why modules, and at least this one has been answered. One, the temporal resolution.
Mbafite company.
This is new.
Mbafite company yo consultants. Yeah, consultants.
Chairman, mute.
Anna, I'm requesting you please to mute yourself. Thank you.
So we had a question, you made a small argument. Why modules? And the answers are there. Temporal resolution of modules is 1 to 2 days. So at least this has been done. And we concluded that not all images can have both the attributes of a good image. You have to sacrifice one, either the spatial or the temporal, and take the interest of the scale. How do we download our modules data? And what are the sources? At least the mostly used website is the Earth Explorer, which is owned by the US Geological Survey under the US government. This website has other websites like glovis.usd. It has Earth data. But in this session, we shall use Earth Explorer.usds. But anyone who is advanced enough, you can also go for Earth data. You'll find the same data that we are going to download. However, the downloads here, they may not be direct. You will download, but it will take you a lot of time processing. Therefore, we came up with a package called Modis TSP package. This is embedded in the ARA software. And the advantage of this package, that it does the automation of downloading of Modis Landsat products, and it automates the processing and downloading of Modis Landsat products in a time series. So with this package, you'll find that it will download, project, reprocess, it will mosaic, and it will also resize and mask. And you'll get a final output ready. All this will be done in the background. So as we said, this is the ARA package. The requirement for this, you have to have the ARA software. And this is the link. I don't know whether it was shared on your mails or in class. But if it was not shared, these slides are going to be shared with you. Just click on it, as I'm going to also click on it. Practically, we are going to see it. So some of us, we may start fearing. As we can see here, we are seeing some error packages and they look to be codes. Don't mind. Everything has been worked upon for you. So some of the packages that I summarized here, that will bring you to the Modis TSP GUI interface, which is on your right. When you get this interface, that means you'll be ready to start the serving of the food, which is downloading the data, as we shall also see. But to build this interface, you have to download ARA setup, open it, it will bring you an ARA console. ARA console, it is a working space that is just ready for you to put the packages for installation. So we shall have the update package. The update package is important, whereby if at all you have an older version of ARA, maybe with even all the packages inbuilt, we can put it in the console, press enter, then it will install from one of the repositories. But it will take longer. It can take you 1 hour, depending on the strength of the internet. So this is where I said, I'm going to give you my WhatsApp. Some of these configurations will need you to text me on WhatsApp, then we interact. It may not be enough of coming tomorrow, bringing maybe an error, and it will be solved there and then. Most of these errors, programming errors, some of them come depending on the type of the computer you have. You might have security features, for example, firewalls on your computer, which need to deactivate. You might have an antivirus which may not accept the installation of some of these softwares. You might have, for example, you might have QGIS and you're having an older version. The advantages of QGIS, it comes with some of the packages. And you find that most of these packages that are put here, they're already in QGIS and they're working. You only put install package Modis TSP, and it will start there and then. So there are a number of hindrances that can let us do this maybe behind the class. That's why that's why at the beginning, I told you, I share my WhatsApp for you to help you. Besides, you're a big class. I may handle 1, 2, 3, or 10 people a day. Then the next day, other people come in. For those who are interested, you can reach me on WhatsApp to help you to configure this. That is if you fail. I would like to help someone after failing. So there is also another package for backports. Backports helps us to address the security faults. For example, when this interface maybe is successful, you may input a wrong figure within the date or the date format. It has to bring a pop-up, wrong date. Those are the security faults. Then install package language. This one installs a number of languages within the ARA library that can help us at least build this GUI interface. Such languages may the C languages, HTTP, PHP. These are IT language, but it's okay. You may not know that. So we also have the package RDTK. This helps us to build the interface the way it is, the color, something like that. Then we also have the map edit. As we shall be going through the interface, you'll find that we need to call the administrative boundary of a particular area of interest. When we call it, it has to check the projection system of the map. So that's where the map edit comes in, so that it throws the administrative boundary on a world map. So thereafter, after putting all these packages, then you paste the install packages modis TSP, which will help us to do the automation. Then the library, where you see load modis GUI. After all these packages being successful, then we check in the library. The library is where all packages are stored. Then we check the library modis. Is this modis package installed? If you put library modis TSP and it brings an error, that means package modis TSP has not been successful. But if it doesn't bring an error, then you call the modis TSP, and this GUI interface will open in any browser. A browser may be Firefox, Google Internet Explorer, but this does not mean that you should be connected on the internet. No, it will just connect on the local host of your computer. So how did we process this data? And as we said, this was automated. As we said, this was automated. When this GUI interface opens, we shall be able to define the user extent. The user extent may be the location of where we want to download, maybe the administrative boundary of any country. It will be able to reproject the images to the desired projected system, either geographical or projected. So all this has been explained to you in the former classes, the projection system. So after giving us an output as projected, it will be able to mosaic. It will be able to mosaic. It will be able to mosaic all the tiles that has downloaded. Mosaicing may mean putting together the tiles. For example, if it has downloaded 2 tiles, it will join them together so that you get one tile covering a particular country. However, this data will come in hierarchical data format. Hierarchical data format, this is a data type that stores a big, that has a bigger storage of files. So any big files that is downloaded from these images is given to the user in form of hierarchical data format. Some of them call it high definition files, but however, these HDF files are not projected. So here we shall be able to convert these HDF files to GeoTIFF files. GeoTIFF files, these are files that can be read by Envy, QGIS, Eradas. So I don't want the participants to be threatened. I'm only used to ArcMap. How will I use this data? Please don't mind. Yourself, you'll use this data in the format that you use to the GeoTIFF. That's how we shall do the processing. So, however, this data, as we know, the NDVI values have a range between 1 and -1. After downloading and processing all this data, the way we explained earlier, it will come with higher values, which will be between 10,000 and 60,000. -10,000, 60,000. But don't get scared. MODIS has a scaling factor, which is 10,000. So the solution to this, the output data, you'll have to only divide it by 1,000. So by 10,000, or multiply it by 0.0001. and you rescale it back to the NDVI known values, 1 and -1. So we shall be using a raster calculator, and also we shall also calculate an annual average. Being that the data downloaded will be covering a particular year, if you would like to have the average statistics of that particular year, then we shall calculate the annual average of that particular year by using still a raster calculator. But remember, after doing all that, some of these tails, however much it clipped, which we called resize, as you'll see in our GUI interface, we shall be able to resize, maybe we draw a bounding box around the country of interest. Some of the parts on the neighboring countries will be captured. So yes, it is good we have resized, but it's not accurate. So for that case, we shall be using the available administrative boundary of that particular area of interest. Then we shall mask so that we may get the accurate output of that area, ignoring the areas that were accidentally captured when we were resizing. So after our practical session, which we are going for, how the MODIS TSP GUI interface is designed. This will be an assignment, and it will be put in our classrooms. I expect it may not be easy, one especially configuring the MODIS TSP as we said, but some computers may be successful. You'll find that frequent users of the latest version of QGIS, they may bypass most of these packages, and you'll find they are few. So if you're successful, I request that every participant will download his or our own data, or MODIS data for a particular country, a particular year. For example, you will download maybe Rwanda for a particular year, 2020. You do all the processing with the help of the GUI interface. Then you do the downscaling, the averaging. Then you give me a final map with its statistics, the legend, and all the components of the map. But please note, this downloading will take time. The output of this download will be something like 50 GB. After rescaling, if at all maybe we ignore the high definition files and they are not saved, the output will be almost 10 GB. And this download per year, I promise you, it will take 7 hours per year. So you have to have passion. It is assignment which I know can't be done today or tomorrow, but at least if at all you have passion, please try. Try, especially to most of us, you'll find we are students, we are consultants. The method can help you when you want to complete other tasks. So please try so that you can get the skill. Let's try to switch to the practical side. Let's first try to go to Earth Explorer. We see how we can download MODIS, and we see the disadvantages of using Earth Explorer vis-a-vis the MODIS TSP GUI interface. Though it will also link to Earth Explorer, but at least this one is manual. MODIS TSP, it has a bit modified. There is an automation. We shall see, let's first go to Earth Explorer. I'll click directly to Earth Explorer. Let me go to my browser. So this is my Earth Explorer. Yeah, this is a platform where at least we can download most of the free images. We can get the Landsats, we can get the Sentinel, we can also get the MODIS. So let's try. One, to access this platform and download the dataset from here, you should have registered and log in using your username. As you can see on your right corner, I'm already logged in as username Magaya2. So I advise anyone who would like to use this platform should first log in, sign up. Sign up is free. And the advantages of logging in most of these platforms where you download data, the same username and password is the same which is carried on to other mother sites like Earth Data, Glovis. You'll end up that you don't repeat the sign up. The same password and username will be used at least on all those star sites. So maybe let's start. We are not going to download, but we are going to try, and I'm going to at least to show you some of the hindrances that we can get when we are downloading here. Then we switch back to our interface very fast. Then we shall compare. So I'll select the address first. When I go to select the geocoding method, I'll go to address. Maybe let me just put Kenya. Kenya. Click on Kenya, it will take me direct to Kenya. Let me select the range of data that I want. Remember, when we are working with MODIS, it has to be between 2000 to date. So I don't expect you to put data from 1990. You will not get any output. So let me put maybe 2014. I'll start with January 1st, 2014, then to December 31st, 2014. If I want 1 year, then I'll click on dataset. When I click on dataset, then I'll go to, as you can see, a number of imageries are here. As you can even see the commercial satellites are here, but you will have to pay. Just a moment. Sentinel, you see it is here, Sentinel-2, you can download from here. Landsats, they are all here, depending on what you want. So we shall go to NASA. Then I will go to MODIS Vegetation Index version 6. Version 6 is the latest MODIS that we are using. Let me pick any. Let me check this. Let me check this. Then I go to additional criteria. Let me reduce on the filter. I don't want images of night time. Let me just pick day so that I can reduce on the filtering. Then when I go to results, yes. So when you check here, let's first look at the first image. The first image. This is 24th, 12th, 1919. So I think he has brought all. Maybe, okay, let's go to 2014. Yeah, 2014, no, it is 12th, 2014 on 19th. Then there's one for 3rd. So this one will lead us to download image per image, and wait for it to complete. But the advantage is MODIS TSP package. You'll just put the scale of dates which you would like to acquire the images, and the software will download all, collect them together, mosaic them, mask them, reproject them, then give you output. So these are the small hindrances that I was talking about. Now, besides that, this part, you may not know why it is covering. Let me try to swear it is covering. When you look at that, it's covering Lake Victoria and part of Kenya. But remember, our pointer is in Kenya. So it is very difficult to identify which image belongs to the upper part of Kenya, so that at the end of the day, we join them together. So you'll take a lot of time. At least this method, we used to do it earlier when this tool had never come. But since there is another method, let's appreciate the changes in technology, and we see the difference compared to the Earth Explorer methods of downloading. So then let's go back and activate our Modis TSP. We have seen how to download data from there. We want to compare with our Modis TSP. So you'll find that my Modis TSP has already been configured. As I told you, it takes time. I had to configure it. Besides, I've been using it. So I had to configure it earlier so that we could go on with the class. Let me share. So I've just shared the screen of different codes that we have in our PowerPoint. I'm going to share this with you in the class. So the beauty with this, you'll just copy the way I've done. So it doesn't need you to cram all these words. I'll just copy. I'll not copy the number. The number is just telling us the number of packages. So I'll copy that library Modis TSP to check if the Modis package has been installed. If it is successful, then I'll also copy Modis TSP and the GUI interface will open. So I'm still fighting with the technology to share the ARA interface, but anytime, please. So when we open our ARA, it will bring us the console, as you can see. That's how it looks like. You may not mind about what is in the menu bar, but like any other software, these words are English words. Source ARA code. If at all you have a code already, you just import it. But I know this copy, paste, packages, load packages. If at all you have the packages, you see update packages. One of the first package that we have is that you can either click there or put it there manually. So let's continue. I'll just copy that library Modis TSP, press enter. It is checking. The moment you don't see any error, that means the package is already installed. Then you type or copy the package Modis TSP. The only problem with this program is case sensitive. If you type small letters, it will give you an error. So when I click enter, the GUI interface will be displayed. I would just like to know if you can see the GUI interface. Can you see the GUI interface? It has a green bar. Hope I'm not alone.
Not yet.
When it comes to, okay, it is there. When it comes to coding, that's when you hear people are keeping quiet, but this is a friendly language. So that is the output after putting Modis TSP. So that is the GUI interface. When you look at the menu, let's focus on the left, we shall see the products. The products, we shall see the different indices that can be derived out from the Modis data sets. So let's start with the the data and layers. We shall handle one by one. As we handle, we explain. So when we click on the product and layers, when you come to product category, we shall go for vegetation indices, because at the end of the day, we are focusing to get the vegetation indices. And you know, vegetation indices, we have the MV, NDVI, NDVI, and survey. So let's go to vegetation indices. When you click vegetation indices, still, this GUI interface will ask you, and it will give you the categories of the vegetation indices it has. It has vegetation indices of a 16-day composite, 500 meters. Remember, we are focusing at least here at a lower resolution. However, it is high, but we are focusing at the lowest. And we shall go direct to here, 250 meter resolution. So what you see as MD1321 is just a code. What you see as a star, either it has to be represented by Y or O. When you get a product with M or D, that is a tera. That is a tera. A tera product. Tera product means that it is land. The output is for land analysis. If you get MY, it will be water. So, however, you may not know all that. Just select the lower resolution. But if at all you can differentiate between the platforms, then you can go for the platform and check. You want to download land, data for land, you want to download data for water analysis, or you want both. But remember, I told you, these images are heavy. The moment you say both, maybe it is a big consultancy, World Bank. But anyway, it can even be for research. It depends on why you need it. So we shall click Tera. Then, since we want vegetation indices, sorry, it is not 500, it is 250 here. I've done a mistake. Since we want vegetation indices, so it will give us the available layers that we can get from vegetation indices of 250 meter resolution under Tera. Our target is survey. So if you wanted NDVI, you can just check here. If you wanted MV, you can check here. If you wanted any quality indicators to be downloaded alongside what you want, you can check any of this. But our interest is survey. So I'll uncheck this, I'll go for survey. Remember the formula that we had in the PowerPoints? So that is it. I remember I had a hint on flood, disaster, something. So you can get also the flood index. So here our interest is survey. We go back to spatial. We have completed with the products and layers. Let's go to spatial and temporal. So temporal will request us to put the particular years of interest. Let me put 2020. No, it is already there. I want to change. Let me put 2019. 2019, January 1st, and even be helped with the calendar to December 2019 to December 31st. So that means I would like products that are spanning within a full year. The projection user identified, because at least everyone knows the projection of his own country. When we click change, for example, if it is Uganda, it is 36 north. We're in 36 north data. If it is Rwanda, you put 35S. That is the data. Kenya, depending on the area, but most of it is under 37, but depending. So when you move down here, we shall be asked, do you want to download tiles? These are the tiles. What you see here, which is selected, is the tile. Do you want to use the bounding box? Bounding box, you'll just draw your area of interest. But sometimes you may not be a good user or interpreter of these maps. So if you want a bounding box, that means you have to move to your area of interest. You look for Uganda, you see the time I'm taking. But if you have time, it is okay. Now someone asks, do you want us from a spatial file? Spatial file, that means you have an administrative boundary of interest. You want to load it directly. When I click this, the browser will be active. Then I just call it. It is on the desktop. It's on the desktop, I suspect. Desktop. Desktop. Under training. Then under training, there's Districts 2019 for Uganda. When I click the administrative boundary, the shape file has to have an extension of SHP. When I select, it will take me direct to the location of Uganda on the world map, as you see, and it will draw the bounding box automatically, as you can see. So when I scroll down, this part is done. Then I go back to output formats. So the output formats and folder, one, it will entail us to have a username. We have to show the interface, which site do we want to download data from. This GUI interface was configured that all the data from MODIS is coming from the sister sites. We said Earth Explorer, Glovis, and Earth Data. So these sites usually they have the same username and password. So when download method, when I select HTTP, that means I want this GUI interface to connect to internet. That means you have to have internet to download this. If I select offline, that means I have the high hierarchical files on my computer. I want to process them from my computer. I already downloaded them earlier. But since I don't have them, I'll say HTTP. Then I put my username, Magaya2. As you saw in Earth Explorer, my username was Magaya2. I know my password. I don't know why it has been displayed. Usually it is not, but it's okay. So that is my password. If you put a wrong password, it will not download, it will give an error. So still the program will ask you output option. What is the output format you want? You might want to use this data in ENVI and you think the ENVI format is well read in the ENVI software. But at least the GeoTIFF is a universal format that can be read with all the softwares. Ignore the compression. You can ignore the time series. These are the error stat. These are small summary of files that have data and you can use the web mapping to display the output of what you've downloaded. Ignore the offset, ignore the modify value, but for this part, change only the output format. Let's go to the output folder. So the program also asks, where do you want to save all this work? So here the expectation is after reprocessing, projection, masking, at least a folder should be there where to save. The second one here means modules HTTP file. These are usually I call them the raw files, because these files after being downloaded are the ones that are processed to the values that we may desire to see.
No, we can't hear you. We can't.
You can hear me now? Internet was off, I'm sorry about that.
Hear you.
Let me reshare the screen. So this is where we were. Remember, these files are too big. A folder of only this file, HDF files, you'll find it is around 50 GB, only this. And an output of these files, which are already processed, will be around 10 GB. That means you'll have almost around 60 GB. So let's first create the folder where the processed data will go. You will browse. I'll put on my desktop. I'll go under training. I select. Desktop training. Desktop training. Then I'll put under maybe Uganda survey 2019. I put under TIFF. Then select OK. So you see the address where the files where they'll be saved. These are the processed files. That's where they'll be saved. Then the raw files. Let me locate where they'll also be saved. They'll be saved under desktop, training, survey, 2019, because I'm expecting to download 2019. Then I'll go to main HDF, then click OK. So this is the stream. But if you feel you don't have space, you may decide as the computer downloads the HDF files, it processes them, then it deletes them to avoid space wastage. So if I say delete HDF files and say yes or no, if I say no, that means it will download, store them on my computer and process, but they remain. But if I say yes, after processing, it deletes, then at least I'll have to save space. If all that is done, you go to run modis TSP. The moment I click run modis TSP, they will start downloading in those particular folder. Now, at least I have some of these files, the HDBF and the processed files. Let's assume it has downloaded and it has processed. Let me try to share with you the files. This is the folder I've shared where the GUI interface has saved my work. Under Uganda Survey 2019, it will create a folder. I created a folder main HDBF. These files were processed, as you can see. There will be almost 97. There will be 93 files, but they are 34.8 GB. So depending on the size of the country, it will also, the size taken on your computer will also change. So after processing them in the background, I got the TIFF files. From 93, it changed them to 23 files. So these are also 34.8 GB. So approximately I have 80 GB taken, just that. So when you look at these images, you find that this is a 16-bit composite, the output. I'll go to layer, and layers. We should browse to where they are saved. Then the desktop, I'll click here. Then go to the desktop. They're under training. They're under Uganda survey. Under 2000, my target is the TIFF folder because they already processed. So I'll select them all. I won't call one by one. I'll dot .tif, then run once the output. Let's uncheck anything without final. Uncheck. As you can compare the two, let's uncheck. You can compare with the two. The first value was 0.005, but now here in the final, which is masked, is 0.02. That means some figures were falling in another country. Let's uncheck the one without final. As you can see now, we have the Uganda administrative boundary with the NDVI values. But since they're in black and white, we can change. See that we can easily read them. Right click on Survey Uganda final properties. You go to symbology under render type. You'll check for single band pseudo color. Single band pseudo color. Then you select from continuous to equal interval. Then you'll see the outputs. You can even change to classes. You can make 4 or 3 or 4. When you click OK, that is the output. When I try to interpret my output, areas around the lakes and the city centers, you'll find they are almost -0 or -0.02. So that means around here there are no vegetation, which is characterized by water or trading centers. Then where you see maybe blue, it is characterized by high vegetation health after removing the soil effect. So we can stop here, but at the end of the day, this is the output that I would like for each country. And the final output will be a printed map in PDF. This has been done with Dr. Balaza, how to print a final map. So I expect an output map like this with a legend, a key, a title, and a scale. Then you send to the email that will be provided to you. I got a response here. Kindly, for private reasons, participants in the mailbox have requested that the mode of corresponding is email and not WhatsApp for confidentiality reasons. It is okay. But you see, when you send you send me a request on mail, I will not know that you're online, but it's okay. For anything, send on mail, send on classroom, depending on your urges when you want the solution. But it's okay. Send on mail. It is very fine. So my assignment, will you find it in the classroom or email? The chairman or administrator will deposit it in the Day3 folder. Thank you so much. I've been Magai John Paul. I've been taking you through data download and the processing. Unless there is any question with mandate from the chairman, you can admit any question, or else we close. I give back the mic to the chairman.
Thank you very much, Mr. Paul. It's been such a great presentation. Please, dear participants, don't get worried. We are going to share the steps through which you can download and install the softwares. Whatever he's been doing, we are going to share it via your emails and through the Google Classroom. So don't get worried and scared. Someone was saying here, Mr. Paul, you're running so fast. And since our time is really fast spent, there are a few questions, Mr. Paul, you're going maybe to attend to, and then we shall be leaving. One question came from Emmanuel Omiya, and it said, does deleting HDF save on time as well?
Just a moment, let me hand the question.
And also another quick question came from, oh, okay, please.
You said does deleting HDF files save what?
Save on time as well. And then he added, I mean the downloading time.
No, it doesn't save the downloading time. It only save the storage space.
Okay. And also Brian Maccabee has been asking why 0.0001? Please come again.
Yeah, this is the scaling factor that has been provided by module sites. So they are aware of this, so they gave a scaling factor so that which can be used to descale their data.
Okay, and Christine asked that can RStudio be used to access the Modis download?
Yes, RStudio can be used to download the Modis. In fact, before, because this is a new machine I'm using, but that's what I was using. It is very possible.
Okay, thank you very much, Mr. Paul. It's been such a great presentation. And dear participants, you're encouraged to shift all these questions to the Google Classroom because our time here is fast spent. So let's go to the Google Classroom and let the chat keep flowing. He's going to be on and he'll be attending to all the questions we are having. And all the other facilitators will be on to attend to all the questions in the Google Classroom. You can also send any question via info@geomicafrica.com. Thank you very much. And another one, all the materials are going to be shared on our emails and in the Google Classroom.